Good afternoon, students. Welcome to one more session of your redox reactions, that is grade 11 CBSE. Right, I have picked up this redox reactions chapter which is in the NCERT. I think the first video I have given the introduction of the complete redox chapter. I've also taught you the topic of what actually are the definitions of oxidation, what actually the definitions of reduction. Then I've also taught, I think 6 to 7 definitions I have given in the last video. I've also taught you the classical idea of electron transfer. Right. In this video, I'll be discussing the most important concept of the whole redox chapter, that is solving or calculating oxidation numbers. Why? What is the use of this? Basically, oxidation numbers, you will be using it for doing the redox reaction, balancing of redox reactions using ion exchange method. That's the most important, that is used in acidic and basic medium. Right. So for understanding the concept, first I'll explain the NCERT exemplar for you so that you will get to know. Right. Let's start off, students. Now here, first important thing, there is one question given like this in your NCERT. Let's read this. Identify the correct statement or statements in relation to the following reaction. They have given me one reaction here, zinc reacting with HCl, giving me zinc chloride plus hydrogen. There are a list of 4 questions. I need to say which statement is correct. What is the zinc is acting as an oxidant, chlorine is acting as an oxidant, hydrogen ion is acting as an oxidant, or zinc is acting as a reductant. So all 4 questions I need to answer, but before that I need to understand what actually is the reason, how will I decide oxidant or reductant. So I'll solve this. Now one more thing, here is one more question. This is one more NCERT exemplar only. Here what did they give? Which of the following reactions are redox reactions? So in the previous video, what did I teach? I have taught you what are the definitions of redox reactions or oxidation reduction. Like that, based on that, can we do this question? So we can't do this, we can't solve such questions, because for such questions I compulsory require the concept of oxidation number. So I need to calculate. They have given me 1, 2, 3 reactions, and I have to seek or write the oxidation numbers for this. Judge whether there's increase in oxidation number or decrease in oxidation number, and then we can forward or we can further solve it. So these two NCERT exemplar I have to solve and clearly explain you so that you can finish off the remaining in the book. So for that, I'm going to start a topic called oxidation number. Okay, so let us understand the complete analysis of the oxidation number. Very interesting topic. Let's see. So whenever I have to speak about the oxidation number, first concept you need to know is what is the definition of an oxidation number. A little bit more. Okay, so here if I have to speak about the definition of oxidation number, basically the oxidation number is nothing. It's the real or an imaginary charge. Okay, let us write that and then understand. So oxidation number is the real or imaginary charge which an atom appears to have. So this is an imaginary charge when this appears to have in its combined state, So whenever an atom is together in a combined state, that is with forming a molecule, it will have a charge on it, and that charge is what is called the oxidation number. Okay, ma'am, I have not understood. Let's little bit go detail. First of all, whenever we are assigning oxidation number, there are certain rules which we need to follow. See that and to note it, because gradually I'll be telling where to apply, how to apply. Right. So here 1, 2, 3, 4, 5, 6 important rules you need to remember. So what are they? Suppose if they have given me, right, the oxidation number or oxidation number of an atom. Always remember, if an atom is in free state, free state means, for example, hydrogen is here. So hydrogen free state, suppose if I take an example of H2S, okay. Now see here, hydrogen, what is it? It's a diatomic molecule and it is in free state. In this case, the hydrogen valency or this one is 0, remember. So wherever atom is in free state, the valency is, the oxidation number is 0. Suppose if I take sulfur in which molecule, in which one? In S8, again the oxidation number is 0. So in its free state, always it is 0, remember that. Suppose we take phosphorus, okay students, phosphorus exists as which one? It exists as P4, isn't it? So in P4 also the oxidation state is 0. Now if I take one more, oxygen, O2, it is 0, because these are all free state, elemental state. Ozone, O3, the oxidation state is 0, or the oxidation number is 0. So remember this. Now if I have to speak about fluorine, oxidation number of fluorine, wherever it is, the oxidation number is -1 only, right? Now if I have to take the oxidation number of oxygen, basically oxygen exists in 3 different forms. One is peroxides, superoxides, as well as oxygen fluorides. Suppose if it is in peroxides, so always in peroxides, you know peroxides, I think, no, right? So in peroxides, the oxidation number is always -1. In superoxides, the oxidation number of oxygen is always -12. And in oxygen fluorides means like OF2. So in oxygen fluorides, the oxidation number is always +2. So remember this. So in first is peroxides, -1. And next superoxides, -12, and in OF2 it is always +2, right? So done, remember. And next, in oxidation number of hydrogen metallic hydrides, like lithium hydride, okay, metallic hydrides, sodium hydride. In that case, hydrogen, what is the oxidation state? Normally it is +1, but in metallic hydrides, like as I said, lithium hydride, sodium hydride, calcium hydride, in that the hydrogen valency is always -1 in metallic hydrides, remember. Now if I have to speak about the oxidation number of an ion, always remember, for an ion when you're calculating, the oxidation number is equal to the electrical charge. So in oxidation number of an ion, oxidation number is equal to the electrical charge, remember this, okay, done. Next, if I have to speak about the complex ions, we have complex ions. In that complex ions, okay, ma'am, what are complex ions? So basically here there's a chapter called coordination compounds which you study, where we have a combination of 2 different salts together which form a coordinate covalent complex, and a complex ion is formed. I'll show you those examples now, right? So here in the complex ion, always remember oxidation number is equal to, remember, sum of oxidation numbers of all atoms, which is equal to net charge on the ion. Okay, net charge on the ion. Ma'am, I didn't understand this. What is this? We will see in the next paper. A little bit example. So first you note the rules. So here I have given in the free state what is example. Here in fluorine what is example. In oxygen, in peroxides, superoxides, and oxygen fluoride, what is the oxidation number? In metallic hydrides, what is oxidation number? Again here for the ions and complex ions. Let us apply all these. Now in the second page, when I have to take the common oxidation states, normally in the periodic table it's divided into S block, P, D and F, isn't it? So here in the first group, the common oxidation state is, let me take a different pen. Okay, in 1A group the common oxidation state is +1. In 2A it is +2. In 3A, it is +3 and +1. These are oxidation states. Why I have given you, I'll tell you, because we'll be applying the examples, right? In 14th group, if I have to take, the common oxidation states are +4, +3, +2, +1, -1, -2, -3, -4. These are the common oxidation state. If I have to go to the 15th group or the 5th group, there, here the oxidation state are +5, +3, +1, -1, -3. Now here in 15th group or 5th group, what is there? Nitrogen is here. So nitrogen, it shows a valency starting from +5 to -3. Remember, +5 to, in some cases like N3H, suppose if N3H compound, there it shows -1/3 also, fractional oxidation numbers. So in N3H, noted, it is -1/3. Right. If it is 16th group, the oxidation numbers are +6, +4, +2 and -2. Okay, this, as of now we are writing this, we will understand gradually. Now if I have to speak about the 17th group, +7, +5, +3, +1 and -1. Remember this. If it is 18th group, it's a 0 group element, isn't it? It is completely filled. So the oxidation number is always 0 for inert gas elements. Hope this is clear, students. Now, with this concept, let us start calculating or noting some examples, or with certain examples, we'll calculate the oxidation numbers. Right. So here are certain examples. Let me put my paper aside. Okay. So here are certain examples which I have taken, and we will calculate the oxidation number for all these. Right. Here they have given me KMnO4. Okay. Just understand. First of all, the one which is underlined is your task. You need to find the oxidation number for those. Right. Now I know elemental form, it is 0. If it is hydrides, what is there? In oxygen, what is there? Fluorine, what is there? Okay, let us apply. Now here in this case, normally oxygen, right? So oxygen valency, if I have to say, it is -2. How did I say that? We very well know oxygen, like suppose, let me take one paper and explain you. Right, my paper. Okay, the same paper I'll take. So if I have to take the oxygen, if I have to say -2, how? Suppose oxygen atomic number is 8, isn't it? So it is, if I have to take in grade 10th syllabus, or 1s2, 2s2 also, no problem. 1s2, 2s2, 2p4. Right here. So what is happening here in 2p4? If I have to take the p orbital, 1, 2, 3, 4. How many are there? The outer, this is the valence. This is the oxidation number. How many? 2 electrons it can give. So that's why it is -2. So I'm applying that. Here oxygen is -2. Okay, right. Here potassium is +1. Okay, this is what is X. Okay, potassium also same thing. How did I write? Let us see. Potassium is atomic number 19. 1s2, 2s2, 2p6, 3s2, 3p6, 3p7, 7, 8, 9. So if I have to see the p orbital, third one, 1, 2, 3, 4, 5, 6. Now 3p7, 7 will not be there, 3p6 only, no, and 4s1. So 4s1. So what is this one? So 4s1 half filled. So this is the valence oxidation number +1. That's why I have written potassium as +1. So okay, students. Now just see how to calculate. Write this +1 first. Right. This is over. Then you're going to put a plus. Then X for manganese, which I have to find out. Then plus. Right. Put a bracket. This is the charge on that. So this is the oxidation number -2. How many oxygens are there? 4, which is always equal to completely 0. Now let us solve. So when you solve this, it becomes +1 minus X minus 8 is equal to 0. Yes, students? Yes. Now, further, if I have to solve this, X minus 7 is equal to 0, X is equal to 7. So, what is the Mn oxidation state? It is +7. This is the oxidation state of Mn. Let us do one more, right? So, here okay, here if I have to take H4P2O7, same thing. You need to write for hydrogen, the oxidation state is what? +1, correct? So let us write +1. So for phosphorus it is X, for oxygen it is -2. Let me write that also. So here 4 into +1, done, 4 into +1, then plus 2 into X plus 7 into -2, which is equal to 0. This is fine. If I have to solve this, 4 into 1 is 4. This is 2x. This is plus, and 7 2s are -14 is equal to 0. So if I solve further, 2x is equal to 4 goes on the other side. It becomes 14 minus 4 is 10. X is equal to 10 by 2, which is equal to +5. So +5 is the oxidation state of phosphorus. This is clear, students, right? So here, now, this is one double salt which we have. Let me calculate a bigger one. Let us see. So potassium aluminium sulfate dot 12H2O. One concept you need to remember, whenever you have this water of crystallization, you have studied in grade 10, isn't it? So the charge of this water of crystallization is always equal to 0. Remember that. It's neutral because water molecule is neutral molecule. So the sum of oxidation numbers of all is 0 only. Now let us write. For potassium it is nothing but 1, correct? Plus 1, then into plus 1, right? So 1 only is there, so 1, the charge is plus 1. Aluminium, how many are there? It is only 1 only, plus what is the charge of aluminium? Plus 3. So charge is always in the bracket. Next comes, now I need to find for sulfur. So how many sulfurs are there? 2. So it is 2x, correct? Then plus how many oxygens are there? 4 2s are 8. What is the charge on oxygen? It is minus 2, isn't it? So the remaining all is the neutral molecule. It is charge is 0 only, so 0 and completely it is equal to 0. Now when I solve this, this becomes how much? It is 4 plus it is 2x minus 8 to the 16 is equal to 0. 2x is equal to plus 12. 16 minus 4 is 12. X is equal to plus 6. So 12 by 2 is nothing but 6. So this is the oxidation state of sulfur in this. It's easy, isn't it? Always you need to write the number of atoms here, charge always in the bracket. I think this is clear, students, right? Okay, right. Now let us take one more example here. And important thing, don't get confused, students, whenever you're doing something here. Whenever, like any concept which you're doing, do it clearly, understand that. When you do it clearly and understand that, you will not do a mistake. Most of the students, what do? They, like, you know, they'll be in a hurry to solve that. They'll do it in a very fast, like other students are doing. I have to do it. Don't be in a hurry. If you do it in a hurry, always remember mistakes will happen, right? So do it slowly, do it clearly, so that your teacher or your friend will not point out you, right? Well, let us go to the next example, that is your so okay, little bit mistake I have written here, students. This is plus, no, I'm sorry, this is plus. Okay, right. So which one here? X plus 1 plus x minus 8 x minus, okay, this is correct. Yes. Now here, so when I have to take the MnO2 example, understand here Mn is again x, isn't it? So let us take x, right? Then plus, so how many oxygen atoms are there? 4. What is the charge on this? Valence oxidation number minus 2 is a charge. So and which is equal to minus 2. Normally it is minus 2, equal to this minus 2 is kept outside. When you solve, x minus 8 is equal to minus 2, x is equal to plus 6. So what is the oxidation state of manganese? Plus 6, right? Next thing here again, one more, sodium borohydrate. So sodium borohydrate, let us solve that and see the example of that. So here NaBH4. Now if I have to speak about Na, now let us come and solve this sodium borohydride, right? So in sodium borohydride, which oxidation number I need to find? I need to find the oxidation number of boron. So first of all, I should write the oxidation number of sodium. So that is plus 1. You all know, I think, how I got sodium. I just now 10 minutes back I have told you. Please take that, right? So sodium is plus 1. Then how many atoms are there? Okay, first of all, we should write the number of atoms and put the charge in the bracket. That is plus 1. So boron I need to find, that is x, right? Plus how many hydrogen atoms? 4. What is the charge of hydrogen atom? Now I said in metal borohydrides, remember I given the rule, hydrogen is minus 1. This is metal hydride, metal borohydride, a metal hydride, the hydrogen valence is 1, which is equal to 0, right? Now let us solve this. This is 1 plus x minus 4 is equal to 0, x is equal to plus 3. This is fine, students. So boron oxidation number is nothing but plus 3. So calcium oxide. So calcium oxidation number is plus 2. I need to find for oxygen. So simple, number of calcium atoms are 1 into plus 2 plus 2 into 2 oxygen atoms, x is equal to 0. So when I solve this, x will come to, I think when you take out this in the solve, minus 1. So oxidation state of calcium here is minus 1. Remember, so oxidation number, these are the examples, right? Now here I think what you do, you go to your NCERT, take out your NCERT book and textbook, and there are certain examples given. You can go and solve with this. Nothing, always write the number of atoms outside and the oxidation number inside. How to calculate oxidation number? Once again I'll tell you. Calcium atomic number is 20, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Correct? Right? So here 6, 7, 8, 9, 10. Okay. 10 plus 10, 10, 20. So here calcium, how many it can give? It can give 2 electrons out, isn't it? So that it becomes stable. Yes. Correct. So this is the +2 oxidation state of calcium. Now let's come and do the fractional oxidation states also. So here students, fractional oxidation state, basically what are these? Let me write the definition. So here if I have to write the definition of this, let us see. Fractional oxidation state, or OS means oxidation states. Yes, so the fractional oxidation states are used basically to represent average oxidation states, right? What does it mean? We'll see. So fractional oxidation states are often used to represent average oxidation states, OS, right? So if I take an example, let us take an example and see. Simpler, C2H5 minus is there. Okay, now here the carbon valency is -1, right? So here, so remember why -1? Because here carbon, it is bonded to and less electronegative atom. Hydrogen is less electronegative, isn't it? So here that's why the valency of carbon is -1. Okay, and plus between them the oxidation number of hydrogen here is -1/5. Okay, right, which is equal to how much? -6/5. So what you should understand here, important thing is, whenever an atom is attached to a less electronegative atom, remember students, if an atom is attached to less electronegative atom, the valency of the particular atom is represented like this, right? And now the total ionic charge, if I have to add total, I told no, it is an average oxidation state. If I add the total one, it becomes -6/5, and it is divided, total ionic charge is divided by which one? It is divided among 5 equivalent carbons, means this one is divided among 5 equivalent carbons are there, right? So this is a fractional oxidation state. I'll be doing a video in detail also, fractional oxidation state, after the end of the chapter, because that requires at least 45 to 50 minutes explanation, right? Now here if I have to take the next type, that is oxidation state of covalent compounds. This you need to remember, students. Now basically what should I remember in oxidation state of covalent compound? Let me give the understanding. Always whenever there is a covalent compound, remember single covalent bond contributes 1 unit for oxidation number. Okay, single covalent bond means it represents only 1 unit for oxidation number. Suppose if you have negative oxidation number, means what negative oxidation number means, you will have negative oxidation number for what? For elements with more electronegativity. Means if there is an element with more electronegativity, then they'll have minus oxidation number. In the same way, if the element has less electronegativity, then what will I give? I'll give positive oxidation number to that. So remember this is easy, right? So negative oxidation number for more electronegative atoms, positive oxidation number for less electronegative atoms. And if there is single bond, you will say it is the single covalent bond means one unit, one oxidation number. So always remember one more thing. Here for a covalent bond, at the direction we show the coordinate covalent bond in this direction. This is the arrow which we show, coordinate covalent bond. So here means if I'm showing in this direction, it means this is the donor. Let me take my pen. Okay, so this is the donor, DONAR, and this is the acceptor. Okay, this is the concept, right? If the electrons donated. Now if the donor is less electronegative, if it is less electronegative, and if the acceptor is more electronegative, okay, right, then what happens? The less electronegative will have +2, means I said, see here I have written less electronegative means which oxidation state I give? Positive. The more electronegative means I give a negative oxidation state. That is what is the understanding. So the above example shows that negative and positive oxidation state. Now let us take some examples and see. Right here in this case I have taken certain examples. Let me explain the examples to you. Right. So here I'm taking certain covalent compounds example, so that with this you can solve your NCERT questions also. Now this is a covalent compound. Here it is triple bonded compound. Here also triple, here single bond. Right. Here hydrogen, it is +1. Correct. Now I need to calculate for carbon. Okay, A or X. No problem. Nitrogen atomic oxidation number is -3, which is equal to 0. So A is equal to how much, students? +2. Simple, isn't it? Right? So it's the same procedure, but I calculated in this way. Now here in this case again, what is the oxidation number of hydrogen? +1. Here for nitrogen -3. Now I need to find here in which case I need to find. I need to find for carbon. So this is X or A, which is equal to 0. So X is equal to +2. Easy, isn't it? So here I'm trying to give you the examples of covalent compounds. Now here they have given iron 0.94x. Oh, nice. Let us see this. Now I need to find here in this case, I need to find for iron. Now iron, if I have to take here, what is given? 0.94. That is the ratio of iron is to oxygen. So 0.94 into X -2 is the oxygen number, because here number of atoms are 1 into -2, so which is equal to 0. X is equal to 2 by 0.94, which comes to X is equal to 200 by 94, which if you solve you will get the oxidation number of iron. Right. Now let us calculate for NH2. This is one more example which is given here in this case. So I need to calculate for nitrogen in this way. Right? How many nitrogens are there? Nitrogens are 2. X, because I need to calculate. Okay, change my pen. So 2 nitrogens are 2, so 2x. What is the high valency of hydrogen? +1. How many hydrogens are there? 4. 4 into +1. So that is nothing but 4 plus 4, which is equal to 0. X is equal to 2. So the valency of nitrogen is +2. So this is clear, students. Right. So I have given you an example of how to calculate oxidation number. I have given you examples for covalent compounds, how to calculate. I have given you example for fractional balancing also. I have given you example for this one, what do you say, the neutral salts or the double salts also. Now I'll be giving you one more important thing. Let us see the differences between oxidation number and valency. So most of the students get confused what to do. Let's take this. So here basically oxidation number means, so we have understood till now, isn't it? Now, so always oxidation number is nothing but it is the residual charge. Oxidation number is nothing but residual charge left on atoms when other atoms are removed as ions. Remember, so that is oxidation number. But valency is what? Valency is nothing but combining capacity. Combining capacity of an atom. Combining capacity of an atom. So this is what is the definition. Now if I have to speak about oxidation number, remember oxidation number can be 0 also. So neutral, I told you, free state, elemental state, the oxidation number will be 0. But valency will never be 0. It will never be 0. Remember that. Okay. Next important difference between that. So oxidation number, it refers to charge. Means basically if I say what actually is oxidation number means, it is a charge. Right. So oxidation number refers to charge, right? Here, suppose if I take an example of copper chloride, CuCl2. Here chlorine is -1, correct? Here copper is +2, means -1 -1 minus 2. But here when I refer the same thing in case of valency, copper chloride means what will I write? What is a valency? Valency is 1, copper valency is 2. I don't represent in the form of a charge. I write like this, right? Right. The next one. In the fourth difference, oxidation numbers can be fractional oxidation numbers also. So fractional oxidation numbers, it will be, always remember, valency is always a whole number, never it will be fractional, right? Now next thing, if I have to take the example here, you know, in oxidation number I have taken one element like carbon. Okay, carbon. Here in carbon, if I take an example of CH4, in carbon CH4, what is the valency of carbon? If I have to underline this, the carbon valency here is -4. If I take a next example, CH3Br, here the carbon valency is how much? Here if I have to take, it is -2. Okay, you calculate, you can understand. And next in CCl4, if I have to take, the carbon valency is +4. But when it comes to valency, remember the carbon valency, whether it is in methane, whether it is in methyl bromide, or whether it is in carbon tetrachloride, the valency for all is always 4 only. Remember, so these are the differences between the oxidation number as well as the valencies. Okay students, clear? Right. Now here after this, what are we going to learn? I think till now the concept is clear. With this, let us come and solve the NCERT exemplar question, which I showed it in the first page. They have given me NCERT exemplar to solve. What did they ask me? Let me take that paper, the first paper for you all. Right. So they have asked me they have asked me to tell what actually, whether this is, which is oxidized, which is reduced. Zinc is oxidized, zinc is reduced. Please go to the first part of the video, you will understand. Now I have to solve this. Now see here. Here in this case, let us write the oxidation numbers now. Here according to you, this is an elemental form, the oxidation number is 0. Correct? Now chlorine oxidation number is -1. I told you how to do. This is hydrogen, if this is -1, this will be +1. Correct? Now here in zinc chloride, the chlorine oxidation state is -1, zinc is +2. Always plus and minus gets cancelled, it will become equal to 0. Correct? Now this is elemental hydrogen, oxidation number is 0. Now see here. Here what happens, zinc from 0 it is becoming +2. Hydrogen from +1 it is becoming 0. Correct? Yes. Now what is happening? Let's write. In case of zinc, what is oxidation state? From 0 it is going to +2. So what happens here? There is increase in oxidation number. The number from 0 it has become 1, 1 it has become 2. Correct? So when there is increase in oxidation number, what do we say? Remember, zinc is oxidized. If there is an increase in oxidation number, means this is what is important. Increase in oxidation number means zinc is oxidized. So whichever gets oxidized, it acts as a reducing agent. Remember this. Okay? Clear students? Let's see one more. In the next case, let us talk about hydrogen. If I have to take hydrogen, okay, in HCl, this hydrogen, what happened? Hydrogen from +1 it has become 0. So +1 to 0. So +1 to 0 means the number, what happened? There is decreased in oxidation number. Decrease in oxidation number. So decrease in oxidation number means what, students? Always remember, decrease in oxidation number means hydrogen has got reduced. Decrease in oxidation number means hydrogen got reduced. Whichever gets reduced, it acts as an oxidizing agent. Simple, isn't it? So easy. So for that only I have taught you oxidation numbers to calculate. So this is clear. Now let us come and solve one more example of your NCERT. This is the second example which I have given you. Let's see. So here they've asked me whether these reactions are redox reactions or not. Nothing. As soon as this is given to you, write the oxidation states of the oxidation numbers. So in first one, copper, right? So copper is +2. Oxygen is -2. Correct, students? I'll write with the red pen. Okay. So copper is +2, -2. Hydrogen is in which form? Hydrogen is in elemental form. Correct, no? So elemental form, free state, what it should have? It should have 0. Again, copper also is in elemental form, 0. So here hydrogen, oxygen is -2. So hydrogen is +2. So what is happening in this case? Copper, let us take copper. In copper oxide, what happened? From +2 it has gone to which state? To 0. So what is happening here? There is decrease in oxidation number. Decrease in oxidation number. So whenever there is decrease in oxidation number, what do we say? It is nothing. Last time we've written increase in oxidation number, decrease. So decrease in oxidation number means copper got reduced. Correct? Copper got reduced. Now next case, let us take hydrogen. This is the first one, this is the second one. So here if I take hydrogen, in hydrogen it has from 0 it has become +2, 0 to +2. So what has happened to the oxidation number? The oxidation number has increased. So increase in oxidation number means what happened? Hydrogen is oxidized. Correct? So here both reduction and oxidation are happening. Then what can you say? Hence it is a redox reaction. Hence it is a redox reaction. This is clear, students? Right. Now reaction. Now let us see this example. Right. Here in this case, write the oxidation numbers. Oxidation number is -2. Okay, red pen. -2. Iron oxidation number is +3. Okay, so 3 2s are 6, 3 2s are 6. Done. So here next, oxygen oxidation number is -2, carbon is +2. Okay, please watch the earlier video. You will means in this video only watch how to calculate. Now this is iron elemental state, it is 0. Now oxygen oxidation number -2, so this is +4 because 2 2s are 4, +4 -4. Right. Now in this case, when I have to take first thing, let us take in case of iron. So in Fe2O3, this iron, what happened? From +3 it has become 0. So Fe, so from +3 to 0. So what happened there? There is decrease in oxidation number. Correct? When decrease in oxidation number means Fe has, what happened? Same like this, it has got reduced. Right? Now let us take the next example. Now after Fe, the next atom which we are going to take is CO. So here carbon, what do we see? Carbon. Here in this case, in CO, carbon from +2, it has become what? It has become +4. +2 to +4, isn't it? Now what happened? There is increase in oxidation number. So when there is increase in oxidation number, what happened? Carbon has got oxidized. So both reduction and oxidation is happening, hence it is a redox reaction. Remember, hence it is a redox reaction. If both happen, we call it as a redox reaction. Here, students. Now let us see the last example. So this is one more example which is given little bit bigger reaction. No problem. As soon as they give you the reaction, you need to, what should you do? You need to write the oxidation numbers. So oxidation numbers are clear, isn't it? I've taught you how to do it. Let us write. So here in this case, for boron, oxidation number, okay, for chlorine, what is it? It is -1. I've taught you already how to do. So once again I'll teach. Chlorine is 17, 1s2, 2s2, 2p6, 3s2, 3p5. 3p5 means, let us write this p5. 1 2 3 4 5. What is the valency? It is 1. Okay, -1. Right here. So chlorine is -1, boron is +3. So -3 + 3 gets cancelled. Right, 3 into -1. Right. So in lithium aluminium hydride, hydrogen is -1, aluminium is +3, lithium is +1. Done. Now in B2H6, hydrogen is +1, boron is -3 because your +6 and -3 because 2 2s are 4. Okay, done. Here lithium chloride is -1, lithium is +1. In aluminium chloride is -1, aluminium is +3. Yes, students. Now here when I have to speak about the state, what happened? We'll see whether it is redox reaction or not. here in this case, in boron, in your BCl3, in this case, what happened? What is oxidation state? From +3, it is going to -3. Correct, no? From +3, it is converting to -3. So what happened in the oxidation state? There is decrease in oxidation number. Whenever there is a decrease in oxidation number, that means boron got reduced. Okay, done. Next, let us take the next example. That is, let us take lithium now. No, not lithium, hydrogen. Because why didn't I am not taking lithium? Because lithium there is no change in oxidation number. If I take hydrogen, which one? Hydrogen here in lithium aluminum hydride, it was -1 here. So from -1, it has gone to which one? Where is lithium? This one here. So -1. And here hydrogen is here, so I have to see this. From -1 it has become +1. So what happened? There is increase in oxidation number. So increase in oxidation number means hydrogen is said to be oxidized. So here both reduction and oxidation are happening. Hence the above reaction, we should write, hence the above reaction is said to be a redox reaction. Okay, they are redox reactions, right? Perfect, isn't it? So this is the lecture from my side, students. Thank you for watching. So please watch all the videos from my side. A beautiful thank you. So keep watching my next video. Stay happy. This is Vani ma'am from your side. Stay always happy. I'll meet you in the next video. Thank you.